So let's take a look at one more example because something interesting is going to happen in this particular example. Same rules apply. There are a certain number of blue circles under each red box. We're going to let each red box be represented by X. So I have a black square around each of these I got a black square around this situation, and that situation is manipulated 3 times or multiplied by 3. So I got my X plus 1, but since I have 3 boxes, I'm going to multiply that by 3. And on the right-hand side of the equation, I got X plus X plus X plus 3, or I can say 3X plus 3. So I'm ready to go ahead and solve this thing. I'm first going to distribute the 3 through. So that gives me 3X plus 3 equals 3X plus 3. And, well, wait a second here. Something interesting has just happened. 3x plus 3 is equal to 3x plus 3. We have the exact same expression on both the left and the right. Well, how do I interpret that? I can interpret that by saying that both sides of the equation will have the exact same value no matter what value I put in for x. Let me show you what I mean. If we let x equal, let's say, 7, and I plug 7 into 3x plus 3 equals 3x plus 3, well, that's 3 times 7 plus 3 equals 3 times 7 plus 3. Well, of course, that's going to give me 21 plus 3 equals 21 plus 3, and then 24 equals 24. Seems pretty obvious. But it doesn't just work for x equals 7. It also works when I let x equal negative 34. I just picked a number at random here. So let's let x equal negative 34. Well, 3 times negative 34 plus 3, that's negative 99. So I get negative 99 equals negative 99. So what I can say for sure, what I can say for certain, is that no matter what value of x I put into this equation, it's going to represent a true statement. And so I say x can be any number that I want. So we say x is all real numbers. Or if you want to get fancy, we have a symbol for all real numbers. It's a fancy schmancy R, and that signifies that any number that I put in for x is going to make this equation true. Here's another example. Another situation here. We have the equal sign in the middle. We got the same number of blue circles under each red box, so let's see if we can set up an equation. So I get 2x plus 2 on the left-hand side, and I get 2x plus 5 on the right-hand side. Seems simple enough. Let's go ahead and solve this using my 3 rules for equations. So I'm going to subtract a 2x from both sides. Well, let's see what happens here. When I take 2x minus 2x, that's 0. So I'm left with the statement that 2 equals 5. But I know darn well that 2 does not equal 5. So what just happened here? Well, what I can say for certain is that no matter what value of x I choose, or no matter how many circles I decide are under each red box, these two pictures will never be equivalent. Or in other words, I can never get this situation to have the same number of circles on each side. And you can try any number that you want, but you're not going to make this work. And sometimes that happens in the world of equations. Things just don't work out. So I say that this equation has no solution.